Time to finish off this A2000 board. Since the last time you've seen it, it has had a full recap, one new set of red Worth electronic capacitors. We are going to try and upgrade this 4.4 to a revision 6.2. But before we do that, remember there's a problem with the Zorro slots on the real-time clock. They're not working, so let's try and fix that. But while researching what this board needs to upgrade it, well, I think I actually stumbled across what's causing the problem with Zorro on the real-time clock. And you might not believe this, but remember we had an issue with data line D0 between the CPU and the RAM? Well, it seems there's also an issue with data line D0 between the CPU and these buffers running to the Zorro slots. So if we go on to D0 on the chip, and while it might seem counterintuitive, but the input side of all these buffers, as in the side of these that's connected, to the data lines on the CPU, is actually the left-hand side of them. If we go on to that, D0 should be connected through to pin 2 of U603, and it's not. Data line D1 should be on the pin 3. Well, that's okay. But D0 is yet again broken. Now we can't trace it through the board to a via just at this point. Makes its way to there, but there's a crack in the trace just as it joins onto said via. So that's definitely the problem related to the Zorro slots, or well, at least I hope it is. But equally, I think it's the issue on the real-time clock, because that real-time clock chip, well, it has data lines D0, 1, 2 and 3 presented on pins 11 through 14. D0 is on pin 14 on this, which I think should buzz out onto our buffer here, which it does. But equally, that's going to be broken back to here, back to the CPU. I think that's going to be the problem. So we'll just try and repair this in the same manner as how we repaired all the damage around the CPU. I'm going to expose a bit of copper on the trace. Let's just be sure that we have continuity from that copper across to the pin on our buffer. And yeah, that's okay. So we'll just drop a bit of flux onto it. A little bit of solder. I'm going to try and just get a bit of wire to bridge that. Right, I think we got that okay. I'm working on a bit of a funny angle here, but I think we got it. Let's just test it for continuity. So from the CPU to the buffer, yeah, that's not good. Down to the real-time clock chip, yeah. Hopefully that's the issue fixed. Just clean up a little bit of flux residue here. And I'm just going to drop a little bit of solder mask on that, just to protect it again. And you know what, while I'm at it, there's a little bit of bare copper there. Let's put a bit of solder mask on that as well. There was a large trace just at that point there. I think it's on the 5-volt rail. And it was actually broken, or damaged anyway. So I had to put that sort of bit of leg of a resistor across it there. I'm not sure if you can see it at this angle on the camera, but stuck that in there just to re-bridge that point. Okay, let's test it. Everything is hooked up and ready to go, but swapped out to Kickstart 3.1. just so we can access the early boot menu to see if the Zorro cards are detected or not. Before we do that though, I want to first of all boot into Amiga test kit and we'll run the real-time clock test. So RTC, and yeah, the clock is now detected. That's looking good. Let's stick in a couple of Zorro cards. We'll go with the 8 meg fast RAM card first of all, and we'll power it up while I'm holding down both mouse buttons. So expansion board diagnostic, and yeah, there it is, working. Let's drop in this AT bus clone It's got an installation of Workbench 3.1 on that CF card. We'll need to remove the USB stick from the Gotek. Let's see if it boots. Yeah, we got a flash of activity from the hard drive LED. You mightn't be able to see it just with the camera angle, but it does seem to be booting. Yep, there we are. Fantastic. So that seems to be the Zorro side of things repaired along with the real-time clock. Just another break in that data line D0 trace. What are the odds of that? So the only thing left to do really to this board is to try and upgrade it to a revision 6.2. Or we're going to try and apply some of the fixes that Commodore did between these revisions. Now, I was pointed to this handy guide, this PDF that outlines the various changes made to the A2000 boards with each revision, starting from 4.1 the whole way up to revision 6.4. Although this thing is written in German. And while I did do a bit of German in college, that was 20 odd years ago, and I unfortunately can't remember a word of it. So instead, we'll have to rely on Google Translate. Now, everything that's listed there up to 4.4 should already be on this board. What we're really interested in is everything below that. The first one there being solder a 4.5, 3.3k ohm resistor between pins 11 and 20 of U605. Well, that is U605 there, one of the ALS 245 buffers. Not sure what that means. Solder a 4.5. Where's the original document? Okay. Google Translate is getting itself mixed up a bit. So we are going to have to try and refer to both of these. But it's revision 4.5 and we need to solder a 3.3k ohm between pins 11 and 20 on U605. So between pins 11 and 20 of this chip, that's pin 11 down in that corner there, pin 20 being the last one, or 5 volts, so it's a 3.3k pull-up. And pin 11, if we look at the schematic, that is the BAS signal running to the Zorro side of things. Essentially, that's just the buffered address strobe line. BAS, I'm going to assume that's bus address strobe. Now, interestingly, the 6.2 schematics show a 1k pull-up on that. But if we measure that, well, you can see that's a 10k pull-up, and that's being pulled up by those two resistor packs there. It's probably this one, RP903, and yeah, that's a dead short there. And in fact, actually, if we take a look further down the list of fixes that we need to do, under 6.2, item C here, resistor pack 903 and 908, that is those two, it tells us to exchange those for 1k. So I'm sort of thinking we don't want to fit that resistor there. Rather, we just want a 1k pull-up on that, and we're going to get that by changing those two resistor packs, which we'll do later. So perhaps it's a case that that pull-up wasn't strong enough at 10k, and by fitting the 3.3k, well, you're fitting that in parallel with the 10k pull-up, and a 10k and a 3.3k in parallel. Well, if you're going through the calculation for that, it comes out at about 2.5k. So definitely strengthening that pull-up, although ultimately it seems that 1k on all those pull-ups provided by both those resistor packs, that's the ultimate fix for that. So I think we will just ignore that one. Which actually then takes us into all the fixes just directly at 6.2 there. Because the change at revision 6 itself, well, that was just a change in Agnes. We already have an 8372. And Commodore at that time also changed the type of RAM chips they were using. We're obviously not going to start mucking about with that. Nothing wrong with any of that RAM. And if we go down to 6.2 then, the first thing that we need to do is remove resistor packs 900 and 901. That is those two 10Ks that we fitted last time. But because of the amount of repair work that's been done around these, and in fact through these, if you remember some of the holes through the board where those resistor packs fitted, they were damaged and we had to put lots of little wires in. So to save any potential of me undoing some of that repair work by trying to desolder these, I'm just going to cut them out. And then once we've removed those two 10K pull-ups, we'll be fitting 3.3K pull downs to the side of U603 and 604 here on the CPU's bus side of those. Again, as per the 6.2 schematics, two 3.3K pull downs rather than the pull ups. So yeah, it does feel a bit of a waste having just fitted these. But we did ask the question if you wanted to see this upgrade work done, and the vast majority of you said yes, so let's just do it. Need to try and be careful here not to damage anything. Right, that's one off. Although let's not forget that when I fitted those, they were actually the wrong part, and there's one extra resistor soldered on the bottom side. This one needs to come off as well. In fact, I might just be able to break these off by wiggling them back and forward a bit. Yeah, there we are. And then we're fitting these 3.3K pull downs on the left hand side of these two chips. Common pin on these is the one with the dot beside it. We want the common pin to go to ground. That's going to go on, something like that. Okay, quick test. Everything's all hooked up again. Two Zorro cards in. Does it boot? Yep, we're getting a bit of activity there on the hard drive LED, so looking good. And there's Workbench. Let's just give it something to do for a second while we take a look at the next modification. So next one then is changing those two resistor packs, RP 903 and 908, changing them to 1K. And then after that, actually, there's that other mod again. Solder resistor between pins 11 and 20 of U605, if this hasn't already happened in rework between 4.4 and 4.5. Okay, so again that wants us to go and fit 3.3K between pins 11 and 20 on that one, on that bus address strobe signal. The only thing about that though, if you take a look at the picture of a REV 6.2, this is one here from the big book of Amiga hardware, and while you can clearly see those two resistor packs fitted to the side of those two 245s on the data bus, there is no resistor fitted between pins 11 and 20. And in fact, if we take another look at the A2000 schematics, there is no reference to that 3.3K additional pull-up. Now if you were to fit it along with the 1K pull-up when we're going to change those two resistor packs, that's only going to further strengthen that pull-up. If we run it through that calculator again, it brings it out to about 770 ohms, thereabouts. So ultimately, I don't really see the point. Yeah, it's listed in this engineering guide from Commodore, but it's not on the 6.2 schematics, and it doesn't seem to be on any pictures of 6.2 boards, so I'm not going to bother with it. All we're going to do next is swap out those two resistor packs. Okay, so these two out, and we're replacing them with these. Just going to try and do the same thing again though, and we'll just cut these out. And then I'll just go along and desolder all those legs. In fact, I'm probably better just trying to pull those legs out, aren't I? Because I think they were just getting sucked up inside my desoldering gun there. They'll probably actually clog it up if I'm not careful. And yes, I know I've still got one to unblock there, but I've actually been using this little solder sucker just on a couple of personal projects, nothing that I've been recording, and this thing actually does a really good job, as you can see. And I actually think it's quicker using this than using that desoldering gun. I don't believe this. I must have nicked something there while trying to cut. those resistor packs out, because it seems I've damaged the connection at that point. You know, that's okay there, and that's okay there, but that's not okay if I poke into the trace though. It is. So yeah, maybe don't try and cut them off. And I actually thought I might have damaged one there at resistor position 2 on that pack, but no, that's not actually connected to anything. I'm just going to check this other one though. Yeah, all the rest of that's okay. It's just that one there that I stupidly damaged. So yeah, don't try and cut them off, or if you're going to try and cut them off, maybe use better flat cutters than these. These are a bit worn. There's nothing that we can't fix though. Then before we do any more damage, let's just get these in. If I just solder one leg of them here from the top side, that'll hold them in place for me. Now I can sort of flip it over and do the rest. Just don't want that lying against the Zorro slot, just using the tweezers to prop it a wee bit there. And that should be it. Let's just test that wee repair that we did there again. And since those are now 1K resistors, we should read 1K from that common pin to that second pin there. And okay, 900 ohms. They're probably 1K resistors 10%, so 900 ohms is just about acceptable. Just going to drop a little bit of solder mask on that wee patch wire, and then I want to test it again. Yep, seems to be booting fine. On Workbench there, and it has picked up the 8 meg of fast RAM. So just a couple of things left to do then. If we refer back to the list, the next one is that it wants us to cut off the left connector of R215. That is that capacitor. So cut the left hand side of that. Cut the left connector of 215 and attach it to the left side of C215. Now, where is C215? Way over there. Although we can see a large trace running down here. Do need to be careful here because the machine is switched on, but the trace from C215 from the left side of it runs down along here. It's quite a big trace. So we could cut the left hand side of it there, bend that round, scratch a bit of that solder mask off and make it off onto the trace just there. That is supposed to give us a better video signal, although to be honest, the video signal that it produces, well, to me anyway, it looks just as good as any other Amiga. But recommended modification, so let's just do it. So cut left side of R215 and then make it off to the left side of C215. Follow that trace along. I just need to bend that over like that. And we'll make it off just there. Mod complete, but what did we actually do there? So it was originally connected to 5 volt. That's those 4 pins at the top of the power connector here. But that trace that we have connected it to now, well, it goes to that 3rd pin up on the power connector and nothing else. But if we take a look at our adapter cable here, well, that is also red. That is also a 5 volt. Now, because we're using this adapter and inside my ATX PSU, those are connected. So this is going to make no difference whatsoever. But I think what might be going on here is that with the original A2000 PSU, I think that might be a dedicated video 5-volt rail, because that's certainly where it's headed. I mean, it's coming up here. It goes through here, up through one of these caps, comes out of the board up here somewhere. Comes out of the board up there, and then makes its way down here. I think that's maybe supplying power to the hybrid. I'll need to pull up the schematics. So no, it's actually not supplying power to the video circuit as such. Well, certainly not from C215. Rather, that is just going straight to the video port. What about that 5-volt user? Where does that go? In fact, we can see on this here, note on some systems, R215 is tied to +5 user. That's the mod we just did to reduce video noise. So that 5-volt user, that goes to the DB9 ports as well. It's going to the serial port, and it's going to the parallel port. So basically that just seems to be a separate 5-volt rail. It's separate from all the logic on this. But yeah, probably a bit of a pointless mod, especially if you're just using an ATX PSU like we are. I don't think we'll see any difference whatsoever if we try and power this up. Yep, that just looks exactly the same to me. That took ages to boot, and it's giving us that DFO error there because I forgot to reconnect the GoTech. Anyway, next mod. And so that's going to be the series connection of a 68 ohm and 270 picofarad cap to the rightmost of the 4 solder vias below connector 303, other end of the circuit to ground. This solves the molly problem. What's a molly problem? Is that another display thing? I'm not honestly sure, but let's take a look at it. So C303, that is the floppy connector. And the rightmost of the 4 solder vias below it is 5. 1, 2, 3, 4, 5. Am I being punked by Gull Madrid here? There's an obscure reference for you. Right, want to go back to that photo of a full 6.2 board that we found over on the Amiga hardware database. Because if we take a look at it, we can actually see that modification on a 6.2. There it is. There's a capacitor with a resistor below it, tied to ground. And yeah, right enough, there is 4 solder vias at that point on a 6.2 board. So it is definitely the most right-hand via looking at it on that image. We then go back to that component locator that we used in the first part to repair around the CPU. Well, you can see there where the capacitor is to be connected. And if we carefully follow that trace back, it runs to pin 25 on the even CIA. So pin 25, 1, 2, 3, 4, 5. And okay, it is the right-hand most point there. What is pin 25 on the even CIA though? So that is the E clock, nothing to do with video. I'm not really sure what molly problem means then, but it must be a clock issue. That E clock runs at 1/10 of the CPU clock, and it is used by the 2 CIAs, the floppy port, and the serial and parallel ports and whatnot. Basically everything controlled by these 2 things. And presumably by adding the cap and the resistor to ground, we're just helping to stabilize that clock somehow. In fact, that maybe answers one question that was left on the last video about the modification to solve a clock related issue with this board. It must be this one, because I don't think any of the rest of the mods that we've yet to do are in any way clock related. In fact, I wonder can we maybe see any difference in this using our wee scope. So let's get a look at what the E clock looks like at the minute. 704 kilohertz, and to be honest with you, that looks like a pretty good clock. It does seem reasonably stable. Good duty cycle on it. I wouldn't have thought there's any problem with that whatsoever. But let's carry out the mod and see what that does to it. I will hook up the floppy drive again this time, just so we can get it to boot a bit quicker. But let's see if that's done anything to this E clock. And yeah, that looks pretty much identical to me. Like, granted, the resolution of this little AliExpress scope here probably isn't the best, but it looks more or less the same. The only thing that's maybe slightly different, the voltage peak to peak is ever so slightly lower now. I think it was about 3.3 last time. Now it's jumping there between 3.0 something and 3.16. I'm not really sure if that would make much any difference. The falling edge of it does look very square now. I'm not sure it was just that square before. Let's put both images on the screen and you can decide if this makes any noticeable difference. So next thing we need to do then, item 4, install the voltage monitor PST518B instead of diode 802. Well, that is diode 802. That forms part of the power good circuit for this board, basically holding the machine in reset until 5 volt comes up stable, then it releases it. Supposedly by doing this mod it eliminates a power on Guru. Now I know certainly in the likes of an A500, if you toggle its power quickly it will throw a Guru. So I'm assuming it's fixing that sort of similar problem with this 2000. The only thing about this mod though, I'm not 100% sure where we need to make off the 3 pins of our voltage monitor. Now I couldn't get the exact part number. They just don't seem to be made anymore. So rather we've got this equivalent, which is an MCP 120-450Di. Same package type and supposedly pin and specification compatible. So this hopefully will just be a drop-in replacement. Pin 1 of it needs to go to the cathode position of the diode. Pin 2, I have no idea what that says. That's obviously a translation error, so we'll need to have a think about that. Pin 3 goes to the anode of the former diode. So let's get said diode out of there first of all. So the anode of this is at the top there, the cathode being at the bottom, as denoted by the symbol on the motherboard. But what does that translation mean? Massey? Let's go back to the original German version. I mean, it's probably going to be either ground or 5 volt or something, isn't it? So the translation of Massey from German to English is just mass. I have no idea where I need to make off pin 2 of this. Now you can actually see this component fitted to the 6.2 in that image, but it's a bit blurry. I can't make out where it goes. But I have found an image here on this other website, Squeaky Tech, where this same person actually has been going through all the same modifications that we've been doing. And they show it as pin 1 being connected to that side, pin 3 being connected to that side, and then pin 2 is onto that via there. And yeah, that's right, because remember we need to take pin 1 of this to the cathode, pin 3 to the anode. So yeah, I need to unblock that hole there as well. That is on a large copper plane there. Can we figure out where that goes? Is that a ground? Yeah. So it's just pin 2 to ground. Then that other leg there is just about making that hole where we need to make it off. Just gonna put a wee bit of flux on that reflow it. It's just not the best joint. There, it's better looking now. And let's give it another test. Does it still power up? No, it doesn't. We've broken it. Maybe that isn't an equivalent part. Although I thought it was. But seemingly not. I'll bet you that CPU is being held in reset. Yeah, active low signal. It's stuck in reset. Let's just do a power cycle. Yep, that ain't working. We may just have to remove that and put the diode back in. Although, let me just quickly check the datasheet for that part, just to be sure I haven't put it in backwards. So ours is the D type package, and we need to connect that up with ground on pin 1, VDD or the supply voltage on pin 2, and reset or the output on pin 3. Right, had to wind up using a little bit of wire there, just because I had previously cut the legs on that component. But I think that's it installed correctly now. So let's try it. We don't need the cards in just to power it up, so let's see what it does. Yeah, there it is. That's now working properly. And so that's pretty much everything we can do to this A2000 REV 4.4. It is now essentially a 6.2. Now, I know you're going to say, Glenn, there was more stuff on that list. And yes, there was. But the next item was to remove a capacitor at position C909. I have been over every square inch of this board twice. I cannot find that capacitor. So it's either not on a 4.4 and was maybe just fitted to a 6.2 by mistake, and then the engineering notes tell you to remove it, or I'm just going blind and can't find it. So if anyone knows better, maybe let me know. If C909 is on this board, where is it? And then the final things, well, they're just down to swapping out the chipset. As we said last time, this board originally would have shipped with an OCS chipset. So it had a Kickstart 1.3 in it. It would have had an 8371 Agnes, but the previous owner of this had already upgraded that to the ECS 8372A. The tech notes tell us to change the Kickstart to a version 2.04, just like this one, but I've got 3.1 in there. I'm just going to leave 3.1 in there. The one thing that we can change though is the knees. So we can pull out the OCS knees, the 8362, and we can stick in the ECS knees, the 8373. The last thing it mentions on that list then is swapping Agnes to an 8375, but we can't do that without major surgery to this board, so we're not going to bother. You can build an adapter to fit an 8375 and give you 2 meg of chip RAM into the socket for the 8372A, but I've done that before here on the channel. It's not the easiest thing to build. In fact, if anyone who's seen that video, you will know how much I struggled with it, and I swore I will never do one of them again. So this machine is sticking with its 8372A and 1 meg of chip. But it is just a bare board. We can't leave it like that. So I do have a case coming for it, and there are a couple of other mods that I'm toying with in terms of putting this into the case. So we will come back to it at some point in the future, but it is going to be a while because I do need to gather a few bits and pieces before I start putting all that together. But that's going to be it for this video, so hopefully you enjoyed what you've seen. If you did, I would appreciate a thumbs up. Why not hit subscribe if you haven't done so already? There's still plenty more yet to come here on CRG, and I'll see you next time.